Welcome to lesson 2.3, using the focus and directrix with parabolas. In this lesson, we're going to look at parabolas and two new items that we haven't talked about, the focus and the directrix. By the end of the lesson, I want you to understand what the focus of a parabola is. On Monday, you should be able to articulate this if you are asked in class. So, the focus has a great example in something that we all know, and that would be a flashlight. So here you have a flashlight, and the bulb is usually right here. If you change where the bulb is inside the flashlight, what happens to the rays of light? Well, they become more focused, or they get more condensed. So this point changes every output around the parabola. So you see now the focus is based on where a point is that relates to all the points in the parabola, and this point we'll call our focus point. On your paper, please write these equations down and get down the important information as far as graphs. So what I would like to draw your attention to is a couple of things. First of all, if you have an equation where the x is squared, it will open up or down. P fits into the equation and is underneath in the denominator of the parabola. So we have 1 over 4p times x squared. If you can find p, then you have just found your focus, and the line that is opposite of your focus is called your directrix. There is a relationship between these two items. Okay? If you have a horizontal opening of your parabola, it would be when the y is squared. Again, you have 1 over 4p, but here the focus is in the x value and is a vertical line that is opposite of your focus. Please pause the video and write the important information down. The first thing that I want you to write down and remember is that this point, the vertex, used to be the most important point when we weren't talking about the focus and directrix. But now we're going to find out that this focus point and this directrix line has a relationship to all the points in the parabola. So if it says to use the distance formula to write an equation of a parabola with the focus and they give it to you, and the directrix is -2, we can go back to our geometry and say, all right, well, the distance from FP must be equal to PD according to this problem. So we're going to say PD equals PF. Write that down. Then we're going to find our distance formula and set it equal to each other. So remember, x sub 1 means your first x, first y, second x, second y. And we're looking at P to D here. So we don't know our x, so we're going to fill it in with x. We do know our y for PD is -2. We see that here. We know our x for the focus is 0, 2, so we'll fill it in. Next, you'll see when we simplify, that goes away here, and you're just left with y minus 2 quantity squared. The square root of anything squared is itself. Again, here we have square root of y minus 2 squared and x squared. So the square roots will go away, and now we can solve. So we're going to see if we FOIL out, means y minus 2 times y minus 2, or y plus 2 here, and this would be y minus 2. Now we would combine like terms, bring the -4y over, and we have 8y, divide by 8. Now we have 1 over 8 x squared. This is now in the format of the focus and directrix quadratic equation. On your own paper, please complete this problem. Use the distance formula to write an equation of the parabola with a focus at 0, -3, and directrix at y equals 3. If you need to rewind and look at the other problem, please do so now. Lastly, I want you to get this problem down. It says identify the focus and directrix and axis of symmetry of -4x equals y squared. Graph the equation. So I want to draw your attention to the y squared. That means it will be opening left or right. We need to get the non-squared term by itself, so we would divide by -4. So now we have x squared equals -1/4 y squared. Sorry, this is just x. Then we need to find the focus, directrix, and axis of symmetry. Well, what does 4 usually have by it? P. So if 4p equals -4, we would find out that p equals -1. Once you know your focus, you can easily put it into the ordered pair -1, 0, and the directrix is opposite of that, so x equals 1. You can then graph it and prove to yourself that you have the right focus and the directrix. Once you have all the important information down, I'll see you Monday for your lesson.